So engine dynamics question always section 1A, part A question. You have question part A 1, 2, 3 ABC. A normally asks you to draw free body diagram. Right, free body diagram. Normally we expect free body diagram here, or you draw the graph normally. If chapter 1 is graph. A question 2 will be free body diagram. B will be solution. Either ask you to use principle of work and energy, conservation case, or second law of Newton to solve. Okay. Chapter 5. Later I check. Yeah. Not yet. Okay. Okay, maybe I forget to upload. Okay. Okay. So example 2, we stop here. Then okay. So observe the procedure we solve. Normally we start with the free body diagram. So polish up your skill in drawing free body diagram. Don't forget the normal force. Even sometimes the question gives you smooth surface, you still need the normal force as long as there is a contact surface. As long as the object is on the surface, you will always have a normal force. Okay. So a principle of impulse and momentum. What is definition of impulse? Is force multiplied by time equal to momentum. Momentum is mass multiplied by velocity. Okay. We continue, look at, in this case, you see, equation of equilibrium will use here F equal to ma. Why F equal to 0? Because in this case, there's no acceleration in y direction. Although you see this one like your static, right? F equals 0. But if you put chapter 2 F equal to ma equation, the a in y direction is 0. There's no a in this direction. Okay. So from here you find your n component. Careful, So you're doing engine dynamics, so we call F equal to ma. Although the solution I give on the screen here, F equal to 0, because there is no acceleration in y direction. Okay. Then you solve using equation, the mentioned equation or instructed equation. So be clear of what means what lah. Principle of work energy means what. Conservation of energy means what. Second Newton law means what. Okay. Okay. Previously we stopped at example 2. Let's look at example 3. Example 3, you're given this diagram. We have pulley system. Then you're given block A and block B with the mass. Block A 3 kg, block B 5 kg. If the system released from rest, you are given initial velocity already. You have V10 or V0. Determine the velocity block B when it reaches 6 seconds. Here. Ignore the mass of the pulley and the cord. Here, ignore the mass of the pulley and the cord, not ignore the mass of the object. Don't confuse. All right. So before you look at the pulley system, first thing you look at the datum. Remember datum first. Datum, where is the datum? Go down positive. Arrow pointing you already. Right? A also go down positive. First step, you look at pulley system, find the total length first. SOP, first step, you look at this one, look at datum, then the next one, find the total length. Why you need to find total length? You can find velocity and between the two body, right? Between A and B. So in this case, again, look carefully. You only have one rope. There's one example previously, we have two rope. So you need to find two rope total length. Here you have only one rope. So you find the total length. So SB plus 2SA equal total length. Differentiate one time, you're able to find velocity of A between B. Differentiate one more time, you're able to find acceleration between A and B. Why you need to find the A? Because in chapter 2, all the force equal to MA. It will help you to solve something from the force, right? So here, then the next step, you look at logic thinking. One is 5 kilogram, one is 3 kilogram. Both release from rest. You release from rest, B will go down, A will move up. So you'll find the velocity A and B will be one positive, one negative. Same with the acceleration, right? So acceleration negative means it slow down or it's the opposite direction. There are two meanings for acceleration. So first you draw free body diagram. This one asks you to focus on B. Ask you to focus on B. So you draw free body diagram of B. So don't confuse yourself. Go and do two body diagram. You look at the question will directly tell you what to focus on, although there are many objects in the question. So in this case, object B. So you draw object B. So here you deal with force, right? Force equal to MA, right? Or impulse or momentum, still we deal with force. So inside pulley system, we only have gravitational force and the rope, which is the tension. A and B will be different tension. B will be pulled by this line, but A will pull by two lines. Be careful on that. You can find A, you can find B, all right? So A will be have two T here, but one of the T contribute to B. Right. So B, so I draw the free body diagram on the screen here. So I believe you can understand what does it mean. Object A, you have two cable, so you have two T there, but one of the T go to B, so B will have the T here. It depends on which you focus on, but here I focus on B. So that's why B, I have W equal to TB, but this rope was connected to A here, so I have two TB here. I have TB and TB, so I have two TB here, right? So once you understand the free body diagram, then you include kinetic diagram. Kinetic diagram deal with velocity and acceleration. In the pulley system, you only need to look at the datum. Datum say go down positive, you just draw go down positive for velocity and acceleration. Okay, don't pandai go and change the direction. Focus on the datum. So here I put in velocity, both go down because datum say go down positive. If later you find negative, it means the direction is different from the datum. Then you do kinetic find the total length and so on. You find the relationship between A and B. Once you have, then you pull principle of impulse and momentum. This one you focus one item and then another item. So you pull item one, you use principle of impulse and momentum. Now principle of pulse and momentum, you try to observe the equation. Impulse F equal to ma equal to the change of momentum, mv. So mv2 minus mv1. Or you can change mv1 plus f dt equal to mv2. Here, what parameter you can find? Mass you normally given, velocity normally given, force you need to find. Time normally, if the question asks you time, then you use time. If the time is given, then normally you will link to the equation of this principle of impulse and momentum. So this one also you need to find normally, right? V2. So equation principle of impulse and momentum, most of the time, you will be given time and force you can find and so on. So these are the formula given, right? And the question will directly tell you, use principle of something. So block A, so principle of momentum, you write mv1 plus impulse equal to momentum number 2. mv1 from rest, so 0. Impulse, you have 2. as long as you have force, here is all the force. So you look at your free body diagram. You have weight and the rope. So each one you have impulse. So for the force W, go up. Here you have a negative because the direction positive go down, referring to datum. Don't confuse yourself. So here, go up positive, go up negative because of datum. So you have negative 2 TB multiplied by the time. Time was given in the question, 6 seconds. Then your W go down positive because datum point down positive. So you have 3 kilogram plus gravity, 9.81, 6 seconds. Mass was given and V2. So here you have 2 unknown. You have the cable tension and velocity at 2. Then you go to B. Still same equation in principle of work and principle of impulse and momentum. Still the same, but refer to the B diagram. Start from rest. So the first one 0. Look at the diagram. Still you have 2 tension, 2 forces, tension and weight. Each one will give you impulse. Right? So again, go down positive because of the datum given. So TB negative times the time, positive W times the time equal to mv. So you have 2 linear equation, solve simultaneous equation. You have 2 unknown, TB and VB. So equation 1, equation 2, you have 3 unknown. TB, VA, VB. You need one more. Where is the one more? Is the pulley equation. Just now you find relationship between V and VB. Substitute back, then you find the 3 unknown. Okay, substitute back, you find the 3 unknown. Okay, so this one is the from the pulley system one. You have 3 unknown, you have 3 equation, you can solve. Okay, just be careful on the negative positive sign for pulley system. All right. Next, still we look into conservation of linear moment, linear momentum for system of particles. So this equation you see on the screen here, you are very familiar. It is still equation, a principle of linear impulse and momentum. mv1 plus all the impulse equal to mv2. I here is individual particles. All right. Okay. So here, if we have conservative, or linear moment, we will remove the impulse. We will remove the impulse from the equation. Then we have mv1 equal to mv2. Okay. Why we can cancel this one? Because when we sum up all the force, the object doesn't, the external force you combine, it balance the system. So we can cancel the impulse. Okay. This is called conservation of linear momentum. The question also will state very clearly. Maybe section B asks you to use principle of linear moment, linear impulse and momentum. You solve, then maybe section C asks you consider the conservation of linear momentum for the case. Then you this one. You will find that maybe the velocity change if you do conservation of linear and momentum. Okay, this is the equation. If the question asks you the conservation of linear momentum. Or you can just memorize the conservation means, in this case, momentum. If you conserve the momentum means momentum before equal to momentum after. So you sum up all the momentum before equal to sum up all the momentum after. You only focus on the momentum. Same with the energy, same with the force and energy just now. Conservation of force and energy means you look at the energy only. So you have two types of energy, potential and kinetic. Before equal to after. So this, you look at this one when we look into rigid body. Yeah. So if the mass of the, we want to find the at the center of gravity, we use this equation, mvg equal to sum of mv. So sum of m will be the same as your m, total m will be the same, so you cancel. So you can get the gravitational velocity or velocity through the center of system will equal to your Vg at number 2. Huh? Let's look at example number 4. So you have a train, and this is also one of the popular question. So you have two objects, all right? You see as a two object, object A and object B, both go into different direction with the V. A is 1.5 meter per second, B with 0.75 meter per second. So in this case, remember you're dealing with vector. So you start with the coordinate system. Where is positive, where is negative? Go to the right, positive, then you go to the right, positive. All right. My normal approach, I look at the diagram. Normally I will choose the biggest value of the velocity become my direction of positive. Because I don't want to get negative value in my calculation. So for example, in this case, my A moving in 1.5, B move in 0.5, so my direction, I will follow A. So I get positive value in my calculation. So in this case, pull the right is positive. Then in your calculation later, velocity for A will be positive, velocity for B will be negative 0.75 because it's moved opposite of your A. Okay. You're given the weight or the mass of A in megagram. Remember to change into unit SI in kilogram. B also given if the car collide and coupled together. In this case, it tells you the scenario. It collide and coupled means join together. Okay. Determine the speed of both cars just after the coupling. This is case number 1. Number 2, average force between them if coupling takes place in 0.8 seconds. In this case, you look at the principle of impulse and momentum. This case, if you look at coupled case, normally the center one, we will cancel. We will only look at conservation of momentum. Okay. So conservation of momentum, you only look at momentum. So all the momentum equal to all the momentum after. Before equal to after. So what is momentum? mv. mv depends on how many objects you have. So if this is 1, so you have object 1, v1, object 2, v21, okay, v11 maybe. It means it's before, right? Then at the second side here, also mv. But if the objects separate, means you have two momentum. M2, sorry, mass doesn't change. M1, V12, M2, V2, 2. Okay, so if the object separate, means you have different mass. In this case, coupled means the momentum after still same, but the mass combined already. So when it coupled means two objects move in the same speed. So basically you combine these two, become same momentum, m1 plus m2, because it's coupled, moving in the same speed. So on the left hand side, still same, right? So important is, do you understand what is momentum or not? Okay. So let's look at the first one. So part A, we draw free body diagram. We draw two objects, right? So what happens if the two coupled means you join together? When they join two together, the force of each other will cancel each other. One force on the left and force to the right. And my x positive to the right, because in my case, I follow the higher velocity. In this case, A is higher than B, so I choose A. Right. So in this case, when they coupled, all the force cancelled and the impulse equation, you can cancel. Because the force inside there was cancelled already. Right. So conservation of linear, like what I explained just now. Before the momentum, we have two body, mv1, mv2, second body. And then after the collision, you have two body joined together. So the mass join already. Okay. So this case is joined together. So you just substitute the value. Remember to change the megagram into kilogram. These only the careless mistakes. So change megagram into kilogram in your solution. So you look at the solution, there's only one unknown in the equation, which is your V2. So the V2 will be 0.5. If you get positive, means you follow your reference. Positive means to the right. So the two objects will move to the right. This one will be the one part of your answer. It will ask you to describe the motion after the collision or after the incidents. Whether the body move to the left or move to the back, or two body bounce back when they hit, like you hit snooker ball, right? Snooker games and so on. So B, average speed between force between them if the couple take place in 0.8 second. Right. So in this case, we will use average velocity. So we look at A first. We look at A. So A will move to the right, positive direction to the right. But the force acting on the body of A is pushing in. You imagine you are the A. You collide with someone, so someone bang you, right? So the force is actually pointing to you. So the force is pointing to you. But why there's a negative F there? Because direction is opposite from your x-axis, where you define all the direction to the right is positive. So here I just put a negative F there to remind myself my force is negative. Of course, you can put positive here with the arrow, no problem. It just help me to remind myself, right? So you write the principle for impulse or momentum also, right? So mv1 equal to impulse equal to momentum after. So you put in there. So you have F average is missing in the equation. Okay. Then you find your F average. Once you have F average, oh, sorry. Yeah, this is a F average lah. Okay. So what is the average force on the B body? Same, huh? If a question asks you to draw free body diagram for B after 6 seconds, after 0.8 seconds, B is B. The force will be this way. Velocity of B will be this way. Okay, you imagine you are the B, you bang, so same lah. You will feel forcing in. Example 6, in a amusement park, right? So you see the two body there. You are given velocity A, velocity B, and both same direction. But you know that this game you do not join together, right? You won't join together in this game, right? Yeah. So you're given a mass of each body, 150, or each is also at 150, same. And velocity was given. If no energy is lost, this is also conservative means lah. If no energy means conservative principle is applied. Determine the velocity after collision. So here, same. You draw free body diagram. A and B, when they bang together. So remember to draw all the forces. So this one is on the ground, right? On the ground. So you have W and NB, and then the force between the two body. Again, you bang someone, you feel the force pointing to you. So you see the two force is acting here. So the force here, you have to read it correctly. Yeah. In this case, you see two force, right? The force on the right here is for the A. This force here is for A. This force here on the left is for B. Because if you are A, you feel what you try to imagine what you feel. You bang, you feel the force is pointing to you, right? Same with the B. So try to read the diagram carefully. Then conservative for momentum, right? Because the force is equal, so you cancel the center impulse equation. This one 0. Then you get conservation of momentum. So all the momentum before were equal to all the momentum after. Here you have two velocity. You only have one unknown. So how you solve? So you have this one hit and separate. So you have two mass and two velocity. So if you substitute the value, you have VA2 and VB2. You still need one more equation, right? So you have equation between VA and VB, the relative velocity between A and B. So you need one more equation. You use conservation of energy. Because this one you use conservator for momentum. It give you two unknown. You cannot solve. You need one more equation to help you. F equal to ma will not help you in this case. So it already tell you, the question already mentioned, no energy is lost. Basically, it give you hints already. Focus on energy. So conservation of energy is only two things, potential and kinetic. So potential kinetic before equal to potential kinetic equal to after. So you use conservation of energy, T1 equal to V1 equal to T2 V2. So under here, what is T1? Half mv square. What is V1? mgh. Does the H change or not? No. So mv1 cancelled, mv2 cancelled because H is 0. Although it's 0, you have to write 0 in your solution. So kinetic energy, again, it refers to if you have two bodies, then you have two kinetic energy. Don't sum them together. In this case, you have two bodies, A and B, so you have one set for A, half mv square A, for B, half mv square V square, and same for the right-hand side of the equation. You substitute, you will get one equation. This is a quadratic equation. Square each side. You have this equation and equation on the right. Take this one, substitute inside here, solve one of the parameter. Once you solve one of the parameters, substitute back, you get another. This is a substitution or solving simultaneous equation, this one and this one. Okay, important is to try to think how you solve the question. Look at the question and then think, do I able to draw free body diagram or not? Okay, and the kinetic diagram. Do I able to draw? And then look at the question, what does the thing that the question asks you? So here you substitute, you will get 2 velocity. You have square root, you have 3 and -2, the two answer there. Practice your quadratic equation finding the roots. X equal to b squared minus 4ac, that one, divided by 4ac. Okay, so that one. You have positive, negative. Which one you need to use? You look at VB. VB, you look at two diagram, the diagram there. Again, I always follow my diagram. I always follow the higher value of velocity. So both same mass, same mass, but one higher. When you bang, always follow the higher velocity, always win one. So the velocity will go to the right. VB will go to the right, right? In normal case lah. So VB go to the right. Does it positive or negative? Who is your positive? Positive to the right, right? So, so before VB is before the collision. Before the collision, will tell you negative. Okay. So after is 3. So you have two value. One is -2. -2 is because this is the quadratic equation. Quadratic equation here, I just tell you that there's this also the speed of velocity for B. Only when only. The time is different. The time is different. So if you draw this on the chapter 1 graph, V versus T graph, you will get negative is, oh, no, positive smiling face. You'll get this graph. So maybe the time here, the V here, you have a, no, sorry, it's V versus S. V versus S, so yeah, you plot on the graph. But here, I believe you can understand. So VB, you have two answer. One is before, one is after. After one is 3 meter per second to the right. Okay. Again, we square the velocity. These two value is applied to B, but the answer is when only. So you get 2, means you see the diagram give you 2, but this one is before collision, negative 2. So after you choose the positive value. Okay. So this is how you work it. So another one on civil case. So you have a do piling. So piling, you hit with the hammer. The Y before the impact is 0.5 meter. You have a datum given. So datum given, normally two kind of question only. Datum given either give you pulley system or energy. Energy that deal with datum is potential energy. So potential energy above the datum give you positive, below datum give you negative energy. So you link with energy, only conservative of energy. Before and after, T plus V equal to T plus V, same. So you're given the mass using a hammer. Hammer 300, power is 800. Hammer fall from rest, so the hammer velocity initial is 0. Height given, spike the top of the pine, determine the impulse. Determine the impulse with the power exerted on the hammer if the power is surrounded entirely by a loose end, so that after shrinking, the hammer does not rebound from the power. So it tells you that determine the impulse. So chapter 1, 2, 3, 4, there's only one equation deal with impulse. It is principle of impulse and momentum. So call that one mv plus ft equal to mv2. Okay, so call that one out and then draw free body diagram. Free body diagram, we have two free body diagram. One is for the hammer, one is from the Pauling. Okay, so free body diagram. So when the heating hit, in this case, I follow the datum. The datum go up is positive, go down negative. So I have two forces there. I use R, you can use F. In this case, I use R, the resultant of force between two body. So on the intersects there. So for the hammer, again, you hit something, you feel something hitting back. So the arrow will be pointing towards the hammer. For the hammer is below R. For the pile is above negative R. So each body have same different feeling, although both are feeling something hitting their body. Yeah, so read carefully the solution I give on the screen here. Positive, sorry, in this case, positive go down. In my solution now, I choose go down. Okay, the rest you read. So I use resistant force, non-impulsive, so 0. Then I have hammer and pile. Weight is can ignore. Okay. So conservative of momentum. So we have two body. So momentum for body 1 plus body 2 equal to after, before equal to after. In this case, the two body was not coupled. The two body after it hit, it still remain as two body, two individual body. So there are two mass on the right hand side. And also two body also different speed after the hitting. So in this case, you substitute by changing the AB just now into hammer and pile, or you can just label for hammer is A, velocity is B. All right. Then the velocity of 2 will be the same. Because hammer does not rebound off the pile. So after it hit, we assume that both move the same speed. This during piling. So you substitute, you find the velocity 2. Then you focus on the hammer, right? Conservation of momentum, normally it will help you to solve velocity. Principle of impulse and momentum. This one, important. This one focus on individual body. Use it to calculate individual body when you want to use the principle of impulse and momentum. Then you cannot confuse already. Okay, so important when you can use or when you cannot use. Normally for principle of impulse and momentum, we will use it to solve for individual body. We look at free body diagram of individual body. So in this case, we look at the hammer. Then we use principle of impulse for hammer. Right? So you can see the free body diagram on the left, and then the impulse momentum principle. So here you substitute and then conservative of energy. You combine principle of impulse and momentum and energy. In most of the case, chapter 4 question, they will come by one pair. All right. When you use principle of momentum, something will be missing in the parameter. And then you try to find the missing component by using conservation of energy. Especially the datum is given, then energy you need to find. Okay. So you substitute the value, right? T is kinetic, V is potential. Again, why potential before the hitting is positive? Because it's above the datum. Right. Then after hitting, reach the datum location, then 0. Potential is 0. From this case, you find your V1. So you have V1, V2, substitute back. Right? Substitute back to impulse and momentum equation. You integrate, you'll find 6 at 3. Means this component, impulse, is the one that you can find. Left hand side, you move to the right, you find the impulse. Okay, next lecture, we focus on impact. We stop here. Huh?